Hello everyone, I'm Karen again, and I'll be doing some practice problems that you guys struggled with on midterm 1 and midterm 2. So this is just going to be review problems for the first video for this week. Again, an ISI for Professor Tang for CHEM001C. So let's get started. So the first problem is calculate the molar solubility of silver chloride in 0.35 molarity at 25 degrees Celsius. The Ksp of silver chloride is 1.9 times 10 to the negative 4. So as you guys know, the first thing that we should do is write the balanced chemical equation. So as we see here, sulfur chloride equals the equals, or like front arrow and back arrow because it's reversible, silver plus chlorine. And we also know that this equation, Ksp, is equal to S squared. S stands for molar solubility. So our goal here is to isolate the S in order to figure out molar solubility. So the way we do that is that we take the square root of both sides to get S equals the square root of Ksp. Some trick that I like to use in order to minimize my errors in math is to first solve the problem using algebraic the algebraic variables, and then plug in numbers in order to make sure that I have everything right first. So here we isolated the S, which is what we want, and then when you take the square root of 1.9 times 10 to the negative 4, which was given to us, you'll get the molar solubility of silver chloride to be 1.4 times 10 to the negative 2. So that's how you go about doing the first problem. Let's see another problem. How many unpaired electrons would you expect for a complex ion, such as this one? Bromine is a weak field ligand, okay? So you are finding the unpaired electrons for bromine here. Be careful, it's not iron, but it's bromine. Sorry, this is a typo, but it's a charge of 2+, so this should be a superscript here. So first we have to determine the number of valence electrons. So we know bromine is right next to the noble gases, right? So it would have 7 valence electrons. However, we know that it's a ligand, which means it uses one pair of these electrons to bind to iron, right? So it would give you 6 valence electrons. So by doing the p shells, right? Here we have 5 different ones, 5 different orbitals, and we fill out the 6 electrons. So we have 1, 2, 3, 4, 5, and then 6, right? Make sure to fill all of them first before you start doubling up. So now that we have filled out the orbitals, we have to look at how many are unpaired. And as we can see here, we have 1, 2, 3, 4. So the answer is 4 unpaired. So let's move on to the third question. So calculate the pH of a solution after adding 10 milliliters of 1 molarity hydrochlorine acid to 0.25 molarity of HCOOH and 0.30 molarity in HCOONA. And the pKa is 3.75. So we know we're familiar with the Henderson-Hasselbalch equation, right? Which is pH equals pKa plus log of concentration of base over acid, right? So let's see if we can plug in the numbers. The trick here is that you have to take into consideration the new volume, right? And the molarity of hydrochloric acid, right? So let's see what we do here. So we do the pKa, which is 3.75, plus log. Rather than just having the concentrations of the base and the acid, make sure you subtract the volume and add the volume here, right? So what we get here is 0.37 minus 0.01 and then 0.25 plus 0.01. Just to clarify, we did convert it to moles technically because it's it's 0.01 liters, and when you divide by 1, it's 0.01 still. So if you plug in this into the calculator, you should get pH of 3.98. And that's how you would do this problem. So that's it for my presentation. Make sure if you have any questions to stop by office hours. We're here to help you guys out. As you know, my SI hours are usually on Tuesday. For next week, week 9, they're going to be on Thursday for 2 hours in a row, and then week 10 is going to be Tuesday, Thursday as requested from 1 to 2. And thank you.